Now, in this question, we have aqueous hydrochloric acid, or HCl, and we're going to react that with this solid sodium hydroxide, or NaOH, and that's going to produce sodium chloride, and it's also going to produce liquid water. And they give us the amount of this hydrochloric acid, and they give us the amount of this sodium hydroxide. And we want to know what is the mass that's going to be left over of the hydrochloric acid. So the first thing I'm going to do is write down the balanced chemical reaction for this. And this reaction's got HCl here, and that's going to be aqueous. So I'm going to put AQ, and then we're going to add that to this sodium hydroxide, or NaOH, and that's also going to be aqueous. And then that's going to produce, so I'm going to make this arrow right here, and it's going to produce NaCl, and that's going to be aqueous. And then it's also going to produce this liquid water. So I'm going to write down H2O, and then I'm going to put an L here for liquid. And what I need to do is balance this reaction. So when I balance this reaction, I'm going to see that I have one H over here, and then I have one H right here. So I actually have two H's on this left side. Now when I go over to this right side, I have one H2O molecule, and one H2O molecule has two H's in there. So I do 1 times 2, and so I'm going to have two H's on this side. So 2 there, and then 2 there. So the H's are balanced. Now I can move on to something like Cl. I have one Cl there, and then one Cl there. So one Cl there, one Cl there. The Cl's are balanced. And now I can move on to something like this Na. I have one Na there, and I have one Na right here. So the Nas, the Cl's, and the H's are all balanced. So the reaction is balanced, and now we can start by putting these numbers down here under the reactants. And so what I have here is 33 grams of hydrochloric acid. So I'm going to write down 33 grams of HCl. And this is I got 22.3 grams of sodium hydroxide. So I'm going to put down 22.3 grams of this sodium hydroxide right here. And notice that I put them under each chemical that they correspond with. And I also put a G here and here for grams. That's because I'm giving grams, not moles. It's really useful to put the units with the numbers for these types of problems so that you can keep track of if I have grams, or if I have moles, or if I have kilograms, or what do I have for my units when I'm working problems like this. And so now that I have that, I'm going to read the rest of this problem, and it says that I have, or I want to find the mass of hydrochloric acid that's going to be left over. So this one right here, the HCl, that's going to be left over. So I'm going to write down this will be left. There's some amount of this left over, and that tells me something about this problem. It tells me that this one right here, if some of this is left over, it means I have more of this than the reaction can handle to make this. So that means this will be in excess. I'll have more of this than what I need to go and produce this. And so this one right here must be the one that's going to be the limiting reactant. So I'm going to put limiting reactant right here. So LR for short. And anytime you're given two different chemicals and two different amounts, that's going to be a limiting reactant problem. And a limiting reactant problem tells you two things for a limiting reactant. It tells you a limiting reactant will be used to determine, it determines two things. The first thing that it determines is how much product is made. How much product is made. And so we don't need to know this for this problem in particular, but if we want to know how much of NaCl or H2O was made, we would look at this limiting reactant, which would be this reactant right here. The other thing that it tells you is it tells you how much reactant is used up. So it tells us how much of this one will be used up. So what I'm going to do is I need to figure out how much of this 33 grams will be used up from this limiting reactant, and that will tell me how much of this will be left over. And so what I'm going to do is I'm going to first convert from grams to moles. And to go from a gram to a mole, you're going to do this equation right here. And that is that a mole is equal to the amount in grams divided by the molar mass. And so what I'm going to do is I'm going to take this 22.3 grams and I'm going to divide by the molar mass of NaOH, and that's going to be 40. And so when I do 22.3 divided by 40, I'm going to get 0.56, and that'll be moles of NaOH. And so what I need to do now is I'm going to go from this one here, I'm going to go from this one to this one, because the limiting reactant, it determines how much reactant is going to be used up of the other reactant. All this, this 22.3 grams, when this reaction is done, this will go to 0. All this will be gone, but this will be some amount used up. And we went from reactant to reactant, so I found out used up of this one. And so I'm going to take this 0.56 right here. I'm going to take 0.56, and that's going to be moles of this NaOH, and I'll put that over 1 like this, and then I'm going to go to the HCl. So I'm going to put NaOH on the bottom here, and then I'll put this HCl up top here. And the reason why I do that is because when I take this NaOH there and NaOH there, those can cancel out, and what goes in here, it comes from the balanced chemical reaction. That's why I had to balance this in the beginning. And so there's a 1 right here, so I'm going to put a 1 right there. There's a 1 right there, so I'm going to put a 1 right there. And so when I take this number here, times 1 divided by 1, and I'm going to get 0.56 moles. Now I changed chemicals, so I'm now going to be HCl. And this will be used up. And so if I have 33 grams of HCl, I'm going to use up 0.56 moles of HCl. I need to figure out how much will be left over. So there is a unit conversion we have to do, and that's why I put a G here in the very beginning, because I need to know this number right here is grams and not moles, and this right here is in moles. So what I'm going to do now is I'm going to take this number right here, this 0.56, and convert to grams. So we'll take 0.56 for the moles, and that's going to equal the grams goes up top, and then we're going to divide by the molar mass. I have moles of HCl, so I need the molar mass of HCl, and that's going to be 36. And so when I do 0.56 times 36, I'm going to get 19.08, and that will be grams of this HCl. And what we'll do is we'll take this right here, this is what is used up, this is what we start off with. So to figure out the answer, we're just going to do 33 grams that we start off with. We're going to subtract what we use up, or this 19.08, and that's going to equal 13 grams. And so 13 grams of this HCl is going to be the answer. So the answer to this will be 13 grams of HCl will be left over.